So in 7.1, the three types of symmetry that we're going to see are x-axis symmetry, y-axis symmetry, and origin symmetry. Okay, so let's just look at some examples of these before we get to the problems. Okay, so on this x-axis symmetry, that's my x-axis, right? The one that is horizontal. Let's see what x-axis, something that would be symmetrical with the x-axis would be something like that, right? It's the same on both sides of this x-axis. Or in other words, if you could actually physically fold the paper on the x-axis, this side would lay on this side. They mirror each other. Y-axis symmetry, same principle, just across the y-axis. So an example of that would be something like that, right? That is mirrors each other across the y-axis. Origin symmetry. Here's your origin, right in the middle, where the x-axis and the y-axis meet. This one's a little more difficult to see. This is what origin symmetry, an example of that would look like. Okay, now the way I like to think about it, there's two different ways you can think. You can think about this rotating 180 degrees and it would land on that, or origin symmetry means you're symmetrical with the x and then the y. So think about this. If I flip this across the x, it would look, if I made it symmetrical with the x, just this half of the graph, it would look like that, right? If you flip this one up here. Now, what if you flip this over there? Wouldn't it end up lying on the other part of the graph? That's what origin symmetry will look like. If you flip the bottom half to the top and then flip it across the y. And if it ends up landing on the other part of the graph, then that is origin symmetry. Okay, these two have other names, or they describe what kind of function they are. This one doesn't have anything fancy. This, if you are symmetrical with the y-axis like a parabola, like that parabola, you are an even function. If you are symmetrical with the origin, you are an odd function. Okay, these are good examples of even an odd function because these are common graphs. Like this parabola is the graph of x squared, right? That's what an x squared graph looks like. That's an even degree function. This is the graph of x to the third power. So this is what x to the third, that's the cubic. You've seen it in math lab, the cubic tool that's over in the toolbox. That's what it looks like. Okay, that's an odd degree function. All right, now let's look at some of these in the homework. I'm going to put numbers 1, 2, and 3 up here at the same time, because there's actually one of each. All right, so I'm just going to recreate problems 1, 2, and 3. All right, let's do 2 and 3 first because they're easy. Okay, on number 2, this one, is it the same on top and bottom, or is it the same on left and right? Left and right, which means it's the same going across this y-axis, right? So this one is y-axis symmetry. Here's mine. X-axis, isn't it the same on top of the x-axis as it is below the x-axis? So this one is x-axis symmetry because it's the exact same above and below the x-axis. Now remember, in order to be, so this one's not x or y, right? Because the top doesn't have a mirror and the bottom. The right doesn't mirror the left. So the only option would be origin symmetry. Okay, so I like to go ahead and reflect this half of the graph across the x and see where that looks like. Because remember, if you're origin, you're going to reflect x and then y. So let's see, if I moved, let's just not even use this part. Let's just use this part right here and flipped it across the x. It'd be right there, right? And then if I flip that across the y, isn't it going to lay on this? So that's why this one is origin symmetry. Okay. 4 and 5. So they don't ask me on 4 and 5 about the symmetry. They ask me if they are even or odd functions. Remember, y-axis symmetry is an even function and origin symmetry is an odd function. So let's see what these look like. There's 4. There's kind of 5. So let's talk about their symmetry first. On number 4, here's my y-axis. Is it the same on either side of the y-axis? So it's y-axis symmetry, which automatically makes it a what kind of function? Right. Okay, this one. So here's my y-axis. It's not exactly the same on the left and the right. So let's do both symmetries. Like, let's say, for instance, if this one flipped upside down and then across the y. So if this side flipped, that would end up right here. This would end up down here. So that's what the first flip would look like, right? If I flipped it across the x. Now, if you flip this across the y, let's see. If this flipped across the y, it would come right here, right? If this, here's my y, it flipped over it, wouldn't it end up right there? So it flips across the x and then the y. So that's why this one is origin symmetry, which makes it what? Odd. Right, that is 7-1. Now, 7.2 is on transformations. What physically moves your graph around the plane? So let's talk about different situations, right? Because let's say you have an x, just a plain x squared graph. So if I just have a plain x squared graph, it looks like that, right? That's the x squared graph. It's a parabola, and its vertex, which is the point at where it changes direction, is right there at the origin. Now, not all x squared graphs look like that, because sometimes it's not just x squared, it's x squared plus 2, or x minus 3 squared plus 4. Those are the numbers that shift your graph left and right and up and down. Okay, right? Because sometimes you have a parabola, but it may be right there with the vertex there. Or it could be over here and upside down. So let's talk about what makes this move to different areas, or what makes it flip upside down. Okay, 3 things happening. And you'll see what I'm talking about when I mention inside and outside numbers in just a minute. I'll let you write it down. So numbers that are inside are numbers that are like inside parentheses, or inside absolute value symbols, or inside a square root symbol. Those are your inside numbers. Okay, what those numbers are going to do to the graph is shift them horizontally, left or right. But you're going to go opposite of what the sign says. So a plus shifts actually this way, shifts it left into the negative number. A minus shifts right. Your outside numbers, which are just not inside anything, right? They're not inside parentheses or absolute value bars or radical symbols. They're outside. Those are going to shift you up and down, and you go with how the sign is telling you to go. Like a plus is going to actually shift you up. And a minus shifts down. Okay, if there's a negative in front of the parentheses of your graph or in front of the X, it's going to flip the graph upside down. Okay, that's what makes that parabola, if it's a X squared graph, be upside down, as if there's a negative in front of your X. Now, saying flips it upside down, even though that's the best description I can come up with, is not really a mathematically term. So the way that MATLAB is going to say it is it reflects it across the x-axis. So those are our shifting rules. So we're going to use these rules. Now, your test that's due on Sunday and the review that's due on Sunday, 7.1 and 7.2 are not on it. They're on the over the next test. Okay, so all the way up to 3.7, which is what we did on Monday, will be on this first test. Okay, let's look at some of these. Right, number one, you have y equals x minus 8 in parentheses squared. Right? The first part of this problem is going to be a multiple choice. It's going to say, okay, what's the shape of the graph that you're going to start with? If you're not sure, put this in your y equals and see its shape. Okay, but this right here is what gives it its shape. So it's going to be an x squared U shape. Okay, so what you're going to have to do is put this x squared in either the A answer, the B answer, the C answer, or the D answer. The difference on A, B, C, and D is where it's telling you to shift the x squared graph. So that's when we look at this. So this minus 8 is inside parentheses. That's what I mean when I say an inside number. So according to my transformation rules, inside numbers shift you horizontally, left and right. But you go opposite the sign. So this is a minus 8. Which means it's going to shift the vertex of this parabola to positive 8, to the right 8. So it's going to shift it right 8 units. Now, I'm going to show you how this is done in MATLAB in just a little bit, because up until now, the majority of the graphing that we've done is we've told it what shape. So we would go over there and pick that shape and then put it in our y equals and get that table with a bunch of points and just choose points out of that table. In this section, it's really focusing on where the shifting happens. So once it's going to start off the same. But then it's going to, once you tell it that you want to put you're graphing the x squared, then then you actually just don't plot points on it. You're going to click anywhere on the graph. And what it's going to do is it's going to put that right at the, with the vertex, right at the origin. Then after that, it's going to give you a little box down here that has shifting instructions. Okay. It's also going to, there's going to be there's going to be several things in there. One of them is going to say vertical or horizontal stretch, vertical or horizontal shrink. We don't have any of that. All we're doing is vertical and horizontal shifting. So don't worry about the stretch and the shrink things that are down in that box. Okay, so what you would do is you would do, this is a horizontal shift, right? You would just go down there and click horizontal shift and then move it to the right 8. It'll be like a little number line bar here. You move, you just drag it to the right 8 and drop it. When you do that, it physically moves this to the right 8. Okay, that's what I'm going to show you when I do the computer and show you how to physically do it in MATLAB. Okay, number 2. G of x equals x minus 9. So same thing. You're going to start off. There's no square, there's no cube, it's just the x, right? So that's the shape I'm starting off with, which is what shape? If nothing's being done to the x, it is going to be linear, a line. Is this minus 9 inside any kind of parenthesis or anything? No, which means it's an outside number. So where is this line going to be shifted? Since that's minus 9 on the outside. Down 9, right? Because outside numbers shift you up and down, but this time you go with what the sign says. So you put it down to negative 9. Right. Number 3. H of x equals 1 over x plus 5. Now, this is not one that we have been working with, that shape, okay? It's not cubed, it's not squared, it's not square root. This is what's called a rational function. And this one's all multiple choice. It's just going to give me 3 different graphs to choose from. If I put this in my y equals to see what shape it is, make sure you put parentheses around your fraction. If not, it's going to put this plus 5 down here in the denominator with that x. So make sure you put that in parentheses to tell it that 1 over x is a separate term than the 5. So just go to your y equals, put the 1 over x in parentheses, then the plus 5 out next to it. So now that's what a rational function looks like. And where did this plus 5 shift it? Is this inside anything? No, which means it's an outside number. So it shifted the rational function up 5. All right, number 4. G of x equals negative x minus 7 to the 3rd. So what's my shape? X to the 3rd is your shape, which means it's going to be that cubic shape. So that's what shape you're going to tell it. when you're graphing. And then you're going to do the shifts. So let's see. Inside, right? That -7 is inside, so it's going to shift it horizontally, but opposite the sign. So since it's -7, it's actually going to shift it to the right 7. This is what I'm talking about when I'm talking about the negative out front. It's going to flip this shape upside down, or in other words, reflect it across the x-axis. So again, you'll physically see that happening, right? The graph, when you click on this and then click anywhere on the graph, it's going to put your x cubed graph right there, and then it's going to give you the shifting box, and you're going to tell it those two things. The first thing you're going to do is say, okay, move the center of this x cubed graph to the right 7. So then, once you do that, you'll see the graph will do that and look like that. Then you'll say reflected across the x-axis, and that's just going to be a little box that you're going to check. Again, I'm going to do one here in just a little bit. So what that'll do is change it from that. So this one, come up here. That one will come down. It'll reflect, it'll turn the graph upside down. Okay, so again, right 7. Moves it from here to here, reflected across the x-axis, flips the red upside down. Number 5, g of x equals x plus 2 squared minus 3. So again, start off with the shape. It's x squared graph. And then let's see where it's going to move on the plane. Let's do your horizontal shift first. So that's my inside number. So go opposite this sign. So I'm actually going to the left 2. And then your vertical shift, your outside number. Go with that sign. So down 3. Number 6. F of x equals the square root. I'm going to do 6 and 7 at the same time. I'm going to put them up here at the same time. F of x equals the square root of x plus 9. So that's number 6. And number 7 is g of x equals the cube root of x minus 3. So the difference between inside and outside numbers when you're talking about radicals, right? This one is underneath that, still underneath that radical sign. That makes it an inside number. On number 7, that minus 3 is not underneath the radical symbol, which makes it an outside number. So that's the difference when you're dealing with radicals to tell who's inside, who's outside. So they're both multiple choice. So let's see, this graph and x square root graphs, that's what they look like. That's an inside number, which means this shape is going to be shifted to the left 9. So the one that has moved from the origin down to negative 9. Root graphs look like that, kind of. This is an outside number, which is an up and down shift. Outside numbers shift you up and down. You go with the sign. So I'm shifting that one down 3. And last one. All right, there's no graphing on this one. It just wants you to say what all the movements are. Starting with your horse, you do it, the order you do it is your horizontal shift, then if there's any reflection, and then your vertical shift. Okay, so starting with the horizontal shift, where am I going? Inside numbers, opposite the sign, so right 5. There is a reflection because of this minus, so then reflect across the X. And then your vertical shift, up 3. Okay, now, just so, I'm going to do one example of the shifting rules. Like it's warm enough. Which one has it? All right, I'm going to do one like number 5. Okay, so this one says inside is a +1. So I'm going to shift it to the left 1 and up 5. Oh, I'm starting off with what? X squared. Shift it left 1, up 5. So here's what I was talking about on the graph. The first thing you do, just like always, is come over here and tell it what shape. So it's x squared, which means that there's my x squared tool that you shape. Now, it doesn't matter. It just says click the graph anywhere. Doesn't matter. I can put it up here in the right corner. So it's just going to give you what the x squared graph looks like without any movement. Then you're going to tell it these two things. Left 1, up 5. Now remember, we're not doing any stretches or streaks, so those don't mean anything for us. So left 1, this is what I mean by opposite the sign, right? If it told it was a +1, I actually went opposite. So I go to there, and then +5 for the vertical shift. And when you're telling it that, it's actually going to move that graph. So see, when I'm moving this left and right, it's moving it. So I need to move it. Let's say left 1, and the vertical shift is up 5. Okay, so it moved it to the left 1 and up 5 for me. So that is how you're going to do the shifting on here. So again, you just plot it anywhere, put the point anywhere you want. The only one that is different is number 2. It's the one that's aligned. So this one's x minus 5, so it's going to shift it down 5 units. So tell it align, just like always. Now, it's actually going to make you plot 2 points, just like always. So you could put that in your y equals and go to your table and get 2 points and plot 2 points on there. That's the only one that doesn't give you the shifting box. Okay, but it's just straight plot points like always. Okay, now let me turn off the recording.